today is launching the 5060 Ti. The 5060 is coming later in May, don't worry. 5060 Ti, this has been a surprising card. Surprising in terms of performance, surprising in terms of a few other things we're going to talk about. But check out the ASUS Prime aesthetic. All of the ASUS Prime cards look the same. This one has even more flow-through, which is pretty cool, but this card doesn't really use a lot of power. It's just got a single 8-pin connection. It uses practically no power. It's actually impressive in terms of the performance that it delivers for the wattage, mostly in gaming. Mostly. I mean, with the frame gen and everything else like that. I think a lot of reviewers crap on the 5060 or 5060 Ti, or I'm going to expect a lot of reviewers to crap on the 5060 or the 5060 Ti. But the Steam survey is where I sort of, maybe not change my mind, but if you look at the Steam survey, the 3060 was an absurdly popular card, an insanely popular card with gamers. This is going to be available in 8 and 16 gigabyte varieties. And so I really, really wanted to take a closer look in case I was just dismissing it out of hand because, you know, there are other graphics options at the targeted $479 to $399 price point that Nvidia shared. And the pricing is all blown up because of the global situation anyway, so like don't even think about the pricing until it's time to buy. Like that's probably not, we're going to talk about pricing. That's probably the least relevant part of this review because it's changing every 3 hours. Let's dive in. GDDR7, PCIe Gen 5, at least 8 lanes worth of PCIe Gen 5, not really the full 16 lanes, but 8 lanes of PCIe Gen 5 is nothing to sneeze at. We've got 16 gigabytes of VRAM on our GeForce RTX Prime from ASUS, and yeah, this is a pretty solid card, GDDR7. If we look at a table of specs for this card, 5060 Ti, it's coming in fairly strong. I mean, you know, all things considered. This is DisplayPort 2.1b, that's UHBR20. We can run high refresh. High refresh 1080p is certainly possible with this card, north of 200 FPS at 1080p in some titles with a 5060 Ti. Frame gen required, yes, but it's pretty awesome. And the DisplayPort 2.1b, ultra high bitrate 20. It's 20 gigabits per channel, 4 channels, that's 80 gigabits of bandwidth. So 4K, 480 hertz with display stream compression. Yeah, you could do that with that physical interface. Nvidia says with the display stream compression, you can still do 240 hertz at 4K, 480 hertz at 1080p, and even with the HDMI or single HDMI 2.1 connection, that will also deliver 4K, 480 hertz, they say. Variable refresh rate, HDR, the whole 9 yards. And this card has a 3-year warranty. That's enough talking about the card and the fit and finish. I mean, it's 2.5 slots. It's got a really, really good cooling design, shockingly good cooler design. It's not really a terribly complicated. I mean, there's only 3 heat pipes here, and we'll talk about power. You also have a performance mode and a quiet mode switch, which by default is on the performance mode, which is great. Even in performance mode, this card was super quiet. It was inaudible inside a closed case from 3 feet away. Like it was not audible over just the background noise of the rest of the system. So, very nice. In a system like this is a Fractal Era 2. It fits quite comfortably in the Era 2 and a lot of other small form factor cases, and perhaps 8 lanes of PCIe Gen 5 is easier to get working on a PCIe Gen 5 riser cable. So those are things to consider if you're doing a build. Generally, I do not recommend riser cables at all for stability, so small form factor machines that use a riser cable of some description. The riser cable can be a mini game in and of itself in terms of stability when we're talking about PCIe Gen 5. Nvidia drivers, black screens and everything else, seems like we're on an upward trend there in terms of improvements. Less of that, less black screens, less chaos from the drivers. But new drivers are dropping today because of the 5060 Ti launch, the imminent 5060 Ti launch. So you might want to update your Nvidia drivers even if you have already upgraded, or you're thinking about upgrading, or if you're still on a 3000 series, or heck, even a 2000 series card, may improve things just a bit. All right, let's get to our game benchmarks. I always like to start with Shadow of the Tomb Raider, because Shadow of the Tomb Raider, even though it's an ancient game, it gives us a nice baseline. And the performance of this card is pretty respectable at 251 FPS average. Now, when we throw in our 4070 and our B580 for comparison, 4070, of course, is last gen, but this one bump up in the last gen. And then our B580 card is a much more inexpensive card, at least theoretically, if we're going off MSRP here. in the current generation. It's one of the first launches. Yeah, the card stacks up okay. I'm a little worried though. The 4070 is 260 FPS, so this is basically almost as fast as a 4070 Founders Edition. Not quite at 1080p. At 1440p, it's basically the same story. Our 1% lows are pretty good, 164 FPS, versus the 4070 okay at 172, and the B580 falls well behind that. So this is sort of setting up the story for the rest of the review before we get into frame gen and multi-frame gen and DLSS 4 technologies, because DLSS 4 technologies is the big bet from Nvidia here. And those do make quite a difference depending on what game that you're playing. I also wanted to take a quick look at Counter-Strike 2, thinking, in terms of esports. And yeah, 705 FPS versus 806 on the 4070 or 522 on the B580. It'll give you a pretty nice Counter-Strike 2 experience. In fact, even the 8 gig model, probably fine for Counter-Strike 2. 8 gigs in 2025, a little worrying though. Like, again, if we look at the Steam survey, 35% of people have 8 gigs of VRAM, and like 65-ish% of people have 8 gigs or less VRAM. But that number has moved significantly in the last little bit. One of the things that I really wish Steam survey would do is group by region, because Steam is adding a lot of users in regions that don't have high-end machines, and so the VRAM breakdown in, say, North America is very different than, say, some of the more rural areas of the globe that are being added to the Steam hardware surveys. So we're trending upwards. We're trending toward 12 and 16 gigs of VRAM, and that is definitely a much better gameplay experience if you're thinking about hanging onto this card for 2, 3, 4 years. Cyberpunk 2077. This is where the rubber meets the road, not just in terms of rasterization performance, but also ray tracing and frame gen. So let's take a closer look at Cyberpunk 2077's default profile. At 1080p, 176 FPS. Again, the 4070 pulls ahead and the B580 is behind. The B580 is significantly behind here, but that card costs north of $100 less. So, just depends. At 1440, there's really not a lot of performance difference between the 4070 and the 5060 Ti. I'm starting to think of the 5060 Ti as a 4070 with more 5th gen features, like multi-frame generation, and better ray tracing. So let's take a look at Cyberpunk's ray tracing. At the medium preset with no frame gen, but that does include FSR, 97 versus 96. Finally, the 5060 Ti is pulling a little ahead of the 4070. We're depending on those DLSS 4 technologies. 1440 remains a very playable 84 FPS, which is great to see. Subjectively, my own experience in Cyberpunk was great, but I'll talk a little bit more about that in a second. Now for frame gen and Cyberpunk, I wanted to go 1x and just go whole hog 4x. 4x frame generation on this card at 1080p in Cyberpunk feels weird. It doesn't feel amazing. And again, I'm playing on a display that tops out at 240 hertz, or at least in this configuration, it's going to top out at 240 hertz. OLED, so very fast pixel response time and all that, as you know if you watch my reviews and my other stuff. There's something difficult to quantify happening subjectively with Cyberpunk when we're doing 4x frame gen with medium ray tracing, and it's not fabulous. Like, it's actually shockingly good, but I think I would actually prefer to play at a 2x frame gen in Cyberpunk. Frame gen, because of choices that the game developer has made specifically in Cyberpunk, it does actually look better on the presets because you lose things like temporal anti-aliasing or there's other stuff in the render pipeline that wrecks things visually. And so it does actually look better when you are experiencing the game with those presets, and DLSS sort of disables some of the stuff that I just don't like about the way that it renders. And there's a mod that you can fix that, and then without really getting into the details. DLSS 4 is an impressive technology for what it's there. I'm not 100% sold. Remember when Jensen was like, oh yeah, 1 out of every 17 frames are real. Everything else is AI generated, or pixels. He was talking in terms of pixels.
The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. Have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames.
This is like an absurd number of pixels are AI generated. I'm not there yet, based on what I've experienced. But DLSS 4, for what it offers in terms of higher resolutions, better fidelity, software upscaling, yeah, there is something there. There is something really interesting there with a combination of good old-fashioned rendering and AI upscaling. And for me, for Cyberpunk, for this specific set of settings, with ray tracing, being able to run at over 100 FPS pretty consistently with 2x frame gen, medium ray tracing, is an incredible gameplay experience for a GPU that's supposed to cost on the order of, $429, somewhere through there, give or take. Well, the base models are supposed to be in that less than $450 range. And we'll talk more about pricing because tariffs and everything else makes everything crazy. That's very impressive, I think. And that is an impressive improvement over the 4070. Now, you can do frame gen with the 4070. You get DLSS 4 with a 4070. And I don't know if it's just software tuning or a little bit of extra oomph in Blackwell, but the 5060 Ti starts to pull ahead in terms of just subjective gameplay experience when we're talking about these new DLSS 4 technologies and things that Nvidia has built specifically for Blackwell. And I think this is an important detail that is probably going to be lost in the weeds in a lot of reviews. And that's why I think details like that, the 3060 was absurdly popular for what it was. The other thing that's weird is this card is 8 and 16 gigabytes. And certainly with these kinds of experiments in Cyberpunk 2077, 16 gigs is going to do a whole lot better than 8, especially if you're going to push into 1440p and you're going to have higher resolution textures. The 5070 at 12 gigs is weird. 5070 Ti at 16 gigs, okay, but it's about a $50 difference for 8 more gigs of GDDR7. That leaves me thinking two things. One, why wouldn't we just go ahead and put 16 gigs on the 5070 of GDDR7 if it's, going from 12 to 16 gigs, $25 instead of $50? Like, where's that at? And that also makes me wonder, where's my 48 gig 5090? That would only be what? Another $100 at most? If it's, there's scaling and packaging and you can make some excuses, but really GDDR7, if the price difference between 8 and 16 gigs is $50, you'd be best off spending the extra $50. But then it's a 5060 Ti, which computationally is behind a 5070 in terms of being able to use the 16 gigs of VRAM. I think there's an aspect of this that is a little bit planned obsolescence. It's just on the other side of find the razor's edge of value, performance, everything else. But that's just my opinion. 16 gigs on this card has been delightful for me, so I don't know. Oh, and at 1440p with 4x frame gen, this is not something that I would recommend. It is a reasonable playable experience, especially with G-Sync or FreeSync at 1440p with 2x frame gen. But again, 4x frame gen, Cyberpunk just doesn't feel right. And that may be because of the number of hours that I've been logging in Cyberpunk just trying to mess with it. Doing a freeze frame and comparison and micro stutters, that's maybe something for the future that I could look into, but I don't know that I'm really discovering something that we don't already know. It kind of makes sense. Basically, 4x frame gen works great if you're getting at least 45 FPS and your 1% lows don't dip below 45 FPS. It seems to me that I noticed that when I would play with the graphical settings and it got below about 45, 46, 47 FPS, that's when 4x frame gen didn't really seem to be contributing positively to the overall gameplay experience. But if I could do between 45 and 60 FPS with the base game, playing on a monitor like this with 2x, 3x, and beyond frame generation was a much better experience. We also had a little time to test Assassin's Creed Shadows. It's pretty playable at 1080p. 1440p is a little bit, 1440p is not a fabulous experience before we get into DLSS 4 technologies. At 1440 with the right graphical settings, a little bit of tuning, 90 FPS was achievable in Assassin's Creed Shadows, and that was a pretty good gameplay experience. I tried doing the Nvidia app override for 4x frame gen in Assassin's Creed Shadows, and I'm not sure this is something I would recommend, but I was able to achieve 189 FPS at 1080p. 1080p, this was a better experience than Cyberpunk, but you could still tell that there's something unholy going on in the background. This is a lot of words around frame gen and DLSS 4 technologies to basically explain these are top-notch smoothing technologies, but if you're not having an amazing experience before you turn that on, or at least a good experience before you turn that on, it's not going to magically make it better. That said, For these single-player games, especially scenarios in Cyberpunk, it is a surprisingly good technology. And FSR technologies for, upscaling and things like that are better than I ever thought upscaling technologies would be. Like, it's really not bad. The other impressive thing about this card was actual power utilization. And I'm not really sure what to make of these power utilization graphs, because I was expecting, like other 5000 series GPUs, this thing to use a little bit more power. But it seems like in most scenarios, it's using a little bit less power than the 4070 Founders Edition. This card is also overclockable, which would have to be a conversation for another day, because this is a lot of flow-through. But the reason this is a lot of flow-through is because there's just 3 heat pipes on this design. So 125 watts, 180 watts absolute max, 125 watts, just normal gaming workloads. So this card uses a little less power than a 4070. So it's surprised that it also has higher temperatures. So the 4070 Founders Edition, this is a little louder and has a little bit more aggressive airflow, exhausting out the back and then through the flow through here. But it runs a little cooler as a result of that. It uses a little more power, but this uses a little less power, but runs a little hotter. Relatively modest heatsink, I guess. The fan profiles certainly weren't aggressive either. So again, all within normal operating parameters. And the hottest hotspot during gameplay on the order of 75 degrees C, give or take. Yeah, letting it run Firestrike continuously in a loop for hours and hours and hours, it really pretty quickly reached its target temperature and stayed there, which kind of makes sense because the profile is like, hey, we'll just let the GPU float at this temperature. And that is a good experience for the end user because it doesn't sound like a jet engine, which is great. Now let's talk artificial benchmarks. Is it really B580 versus RTX 4070? Well, from all of the GPU testing we did, I chose these two specifically because the 4070 is just a hair better than the 5060 Ti generally, and significantly better than a B580. So the 5060 Ti is much better than the B580, but not quite as good as the 4070 from last generation. So definitely better than a 3060 Ti. Well, let's let the artificial benchmarks speak for themselves. First up with Port Royal. Yeah, look at that. It's basically neck and neck. And the 5060 Ti at 10219. Okay, that's not right. The B580 is pulling ahead in Port Royal. Will that translate into the real world? Time Spy, 5060 Ti, that's a pretty respectable 15702. A little slower than the 4070, but faster than the B580. Firestrike, that's pretty much the same story. Now what about Geekbench? Geekbench's Vulkan benchmark is going to test a lot of things, right? It's pretty much the same breakdown. I mean, 136,685 is a pretty good score here. This is better than I was expecting. I wasn't expecting the 5060 Ti to be quite this good. Actually, on the one hand, I was expecting it to be better than a 4070, but on the other hand, it was like, well, maybe not. I also like to test OpenCL, and the B580 here was really bringing up the rear with OpenCL. I'm not sure why, but this is a pretty good score for the 5060 Ti. Now let's talk about AI and AI text generation. 4070. The 5060 Ti is interesting here because 16 gigs of VRAM, generally the VRAM is going to be the limitation. So use Procyon because it's got some canned benchmarks because it'll use Mistral and Llama 3.1, etc., etc. And yeah, the raw compute performance, the raw tokens per second, the 5060 Ti is a little slower than the 4070, but these are really respectable scores. If you're looking for a low-cost GPU to experiment with local models, and you need 16 gigs of VRAM because you definitely need to give AI as much VRAM as possible, the 5060 Ti here is holding its own. It's not doing a bad job. This would be a perfectly reasonable student GPU for AI experimentation. You could run the Windows subsystem for Linux. You could download LM Studio. You could just run Linux natively, because CUDA. There's a lot of options you can do with this GPU. And this is a really significant advantage that Nvidia has in AI. Even modest, the most modest of the modest GPUs from Nvidia have full CUDA stack. This is not yet something that AMD can say about their stack. They haven't really treated gaming GPUs and enterprise GPUs the same way in terms of software stack, but that's a story for another day. The rest of the hardware that we're talking about here with our Blackwells, it's 24 teraflops. 5th gen, floating point 4, floating point 8, floating point 16, 759 AI tops, trillion operations per second. You also have 9th gen NVIDIA encoders and 6th gen NVIDIA decoders. So onboard H.264, 265, 9th gen, yeah, it's it's supported because Blackwell. So yeah, that's the launch of the 5060 Ti. Bottom line, it leans in heavily into DLSS 4, and for Nvidia's claims that they've made, it leans heavily on multi-frame generation. So if you're thinking about this GPU, or you're thinking about doing a build around this GPU, and you're looking at it, go in eyes wide open. I'm always going to recommend 16 gigs of VRAM, especially in 2025, especially if you plan to hang on to this card for more than a year. 8 gigs of VRAM in 2025 is already difficult depending on what game that you play. I mean, Hogwarts Legacy and other AAA titles that make use of high-resolution textures. Heck, even Far Cry 6. Far Cry 6 is ancient at this point, and it can have some really nice-looking textures if you've got the VRAM to support it. And 8 gigs of RAM on a 5060 Ti makes sense because of the performance class of a 5060 Ti. It would be nice if there were, like maybe 12 gigs would be the sweet spot for a 5060 Ti, but it's, the manufacturing, you're sort of getting the choice between 8 or 16 gigs. If you move up to a 5070 with 12 gigs, really the 5070, it's even more of an impetus on moving toward 16 gigs of VRAM on the 5070 Ti. Like you should just, an entry-level GPU, if you're going to spend money on a GPU, 16 gigs is where it makes sense. The other thing that has me a little bit shook is if you look at how good some of the built-in GPUs are now. If you look at what AMD is doing with Strix Halo, if we look at some of the things that have leaked around what Nvidia has been up to, I mean, we're talking about like Project Digits, which is now Spark, and the whole ARM thing. But you know Nvidia is going to have an ARM plus Nvidia laptop. And Nvidia has already spilled the beans on 5060 based laptops, or laptops that include a 5060 GPU, because it is really low power, that are going to start at around $1,100. That's when I sort of realized this part is really a mobile part that is being used in desktop. I think that's just my opinion, and it can be a reasonably okay desktop experience, but really it's meant for laptop, low power, and that's kind of in that APU category. But an APU that can deliver 90 or 100 FPS at 1080p, nobody's going to spend an extra hundreds and hundreds of dollars on a discrete GPU if they could just spend a little bit more on a CPU or a system or a platform and get the same level of performance. The 5070 and the 5070 Ti really does start to look like the entry-level GPU when you're talking in terms of performance. Now, the place where the grenade for that, against that, is pricing. If you're in the United States, I'm sorry, the pricing is just, tariffs are on, tariffs are off, and this kind of tariff is on, but then not the other. Okay, we'll have an exception for semiconductors, but then you still have a baseline 20% tariff. These are products that historically have had 3, 4, 5, 7% profit margins, razor thin profit margins. And arbitrarily getting a 10, 20, 30% tariff on top of that is really going to dampen consumer enthusiasm, and the makers have no choice but to pass that on. But because the margins have been so razor thin for so long, anybody that's anywhere in the supply chain stack is going to be tempted to add even a little bit more margin and blame it on tariffs, because it's so fiercely competitive and there's so much going on and there's so much complexity to unpack there. And the reality may be that a used GPU from last generation may be a better deal, even though you're not going to get 4x multi-frame generation and some of the other 5000 series technologies. Fortunately for its part, Nvidia does, they do support DLSS 4 technologies for the most part on older generation GPUs, and that is great news for gamers. And if you look at the Steam hardware survey, we can see that there's been a lot of churn and, sort of move up the ladder in terms of GPUs and everything else. We've also seen that the slice of the pie occupied by 8 gig GPUs has shrunk dramatically in the last few months. Some of that has been made up with more VRAM GPUs, but a lot of it is really because of the expansion of the market of Steam. A lot of places in China coming online, a lot of places in other parts of the world that maybe don't have the highest end machines are coming online and being added to those demographics. So it's definitely a weird time to be launching a 5060 Ti GPU. To Nvidia's credit, in their own marketing material is talking about the performance gains in the context of multi-frame gen and DLSS 4 technologies. And that is one of the best aspects of this card. That said, my own personal experiences, just playing games on it, 1080p was a great experience. 1440p was a mostly great experience, except for a couple of outliers, not due to VRAM, but really just running up against computational limits. And DLSS 4 and being able to play with the game settings, I was still able to get a good gameplay experience out of those specific games, AAA and beyond. 8 gigs of VRAM is and remains a bit of a constraint when we're talking about modern gaming and moving into more AAA titles. But at the same time, it's like, do I recommend a 5070 over this or competing products or something like that? And it really just comes down to price. Like, what price is it actually in the market versus everything else? How much of that is tariff? How much of that is opportunistic pricing? How much of that is everything else? Whether or not this is a card that makes sense in the market almost entirely comes down to price. There's not anything here that is a definite showstopper in terms of like, oh, well, you didn't get this, you should just, skip on that this generation. If you're on a 2,000 or 3,000 series GPU, you're probably looking to upgrade. If you've got an even more ancient GPU, you're probably looking for what's available to upgrade. So it could be an option. If you look at my benchmarks for the Intel B580, the B580 is still, in terms of like frames per dollar, it's an amazing deal. But the trade-off is there's still little wrinkles and weird problems with the driver and software and things that are definitely untoward with how that works. For example, in Baldur's Gate 3, in doing actual gameplay through for the benchmarking to just, how is the current drivers as of April 2025? I could get into weird situations where the game was at like half the frame rate it should be. It was like 30, 35 FPS, and just quitting the game and restarting it back to 60. And I don't think that was because of messing with graphic settings in the menu or anything like that. It was just weird behavior from the B580 drivers. That was one of the most repeatable things, though. So like you could start with Baldur's Gate in Act 3, loading and unloading things in the city, and you probably would trip over that after an hour or two of gameplay. There were other issues with the B580, but yeah. So anyway, this did not do that. Even with all the problems that Nvidia was having, Nvidia's drivers and driver quality is still top notch, in my opinion. Nvidia does a lot of software engineering to figure that out. That is less of a competitive differentiator in terms of like Nvidia versus AMD. It is more of a competitive differentiator in terms of Nvidia versus Intel. So I don't know, take it with a grain of salt. I'm Wendell, Level 1. This has been a quick look and my rambling thoughts on the 5060 Ti and my own personal experiences just playing games and doing fun stuff here with it. I'm signing out, and I'll see you in the Level 1 forums. If you have any questions, I missed anything, or you want to see me take something specific for a spin. All right, I'll see you there.